Hey everyone, welcome back to my number sense series. In this video, we're going to talk about multiplication, but with a very special case. Now, this special case occurs when one of the two things happens. Either the first digits of the numbers being multiplied are the same and the last digits add to 10, or the last digits of the numbers being multiplied are the same and the first digits add to 10. Now, this is, of course, a very unique case, and if you were to randomly generate numbers, this will not happen very often, but it is pretty common in number sense because they give you these problems on purpose to see if you know how to do them. So with that being said, let's see if we can actually figure out what the trick is by looking at some examples before we derive what it is. So let's look at our two examples. 42 times 48 equals 2016, and 63 times 67 equals 4221. Now, if you remember our other videos, the first thing you might notice is that we have 16 and 21. And what are 16 and 21? They are 2 times 8 and 3 times 7. Now, of course, if you know where the trick comes from, or if you have good intuition, you'll figure out this is not a coincidence. Alright, but then where do 2, 0 and 4, 2 come from, 20 and 42? Well, if you recall the video where we did squaring numbers ending in 5, you might realize that this 20 is 4 times 4 plus 1, and this 42 is 6 times 6 plus 1. 6 times 6 plus 1 is 6 times 7, which is 42. And 4 times 4 plus 1 is 4 times 5, which is 20. So we can kind of predict that if the last digits are the same, if the first digits are the same and the last digits add to 10, then our pattern might be something like, okay, the last two digits are the last two digits multiplied, and the first two digits are the first digit times itself plus 1. But can we actually prove this? And the answer, of course, is yes. So let's write it out. If we were to FOIL out our first example, here's what we would get. We would get 40 times 40 plus 8 times 40 plus 2 times 40 plus 2 times 8. And so how many 40s do we have? We have 40 plus 8 plus 2 is 50 40s, or in other words, 40 times 50 plus 2 times 8 equals 2016. And here we see that 4 times 5 appear, right, in the 40 times 50. But why is it 50 here exactly? Well, it's 50 here exactly because it's 40 plus 10. But it's 40 plus 10 precisely because 10 is 8 plus 2. 8 plus 2, right? We had to have these last two digits add to 10 in order for it to be a nice round number like 50. And this is nice because when we do 40 times 50, we get 2,000, right? And so we just have a 2, 0 in the front, and the 0, 0 doesn't impact anything else in the addition, which is why we can say it's 2, 0, and 1, 6. And of course, this 1, 6 comes from just the 2 times 8. All right, so that's how that trick works. Let's try to apply it here. So I'm going to FOIL it out once more, just so everyone can see what's happening. If you don't need it, that's awesome, but just in case. So when we FOIL this out, we're going to get 30 times 30 plus 6 times 30 plus 4 times 30 plus 4 times 6. And so how many 30s do we have? We have 30 plus 6 plus 4 is 40 30s, or 30 times 40 plus 4 times 6 equals 1, 2, 2, 4. And once more, we'll see that our last two digits are 2, 4, which is 4 times 6. And our first two digits are 1, 2, which is 3 times 3 plus 1, which is 3 times 4. All right. Now, if any of you remember, hopefully you do remember, in two other videos, we discussed the trick for squaring numbers that end in 5, and we also discussed difference of squares. Those two tricks can actually be used to do all of these problems. And personally, I would even recommend using them to do these problems. However, as we get to cases like these, you'll see that the difference of squares and the numbers ending in 5 trick is not always applicable. So it is really important to know how to do this trick instead. But with that said, if you do know that, it can make some of these problems easier. So for our next problem, we have instead a 3-digit number. And some people, when they see this, they're going to freeze because all they know is how to do the 2-digit case. But really, if you understand what is going on, you can figure this out for yourself. So if we were to FOIL it out, I am just going to get the answer real quick to show you what it is and to see how we can translate the trick into that. So we're going to do 400 plus 6 times 400 plus 4, which is 400 times 400 plus 6 times 400 plus 4 times 400 plus 6 times 4. And so how many 400s do we have? We have 400 plus 6 plus 4, which is 410 times 400 plus 6 times 4. And so our final answer is going to be this number, 164024. So how does this 6-digit answer relate to what we usually get? 4 digits, right? 1, 2, 2, 4. Well, what we can actually do here is think of 406. We can think of that as simply being, instead of 400 plus 6, it's 40 tens plus 6. So in our head, even though this isn't really mathematically correct, it does help here to think of it as a 2-digit number where the first digit is just the number 40. So if we do that, then what happens? Well then, at the front we would have 40 times 40 plus 1, which is 40 times 41, which is 1640, right? And at the end we just have 6 times 4, which is 24. And so that really does work. So our next problem is 45 squared. And of course, like I mentioned before, if you remember the trick for squaring numbers ending in 5, this would be very easy for you. And you should also note that 45 squared is 45 times 45, right? And so note that this is actually just a special case of all of these, right? It's just a special case where the two numbers happens to be the same. But it's also that we have 5 plus 5 equals 10, and 4 and 4 are the same. So, if we wanted to, we could do this with this trick, or we could do it with the other trick. And actually here, they are going to be essentially the same thing. What we're going to write is 5 times 5 at the end, which is 2, 5. At the start, we're going to write 4 times 4 plus 1, which is 4 times 5, which is 20. So it's 2025, 1 year before I am recording this. So that is what I call the first case. The case where the last two digits add to 10 and the first digits, quote unquote digits in this case, are the same. So our next case is where the last digits are the same and the first digits add to 10. But you'll see this isn't so different. So let me FOIL this out first. It's 70 plus 4 times 30 plus 4, which is 70 times 30 plus 4 times 30 plus 4 times 70 plus 16. And now, when we add all of this up, what we're going to get is 2516. All right, but where does this come from, really? Well, the first thing we can notice is that, like before, the 16, the last two digits come from 4 times 4, the last two digits being multiplied. That is the same. But our first digit is no longer something like 7 times 7 plus 1 or 3 times 3 plus 1. So what's going on? Where did we get 25? Well, to see where we got 25, let's look at this expression, right? Our number minus the 16, because that doesn't really matter right now. We have 70 times 30 plus 4 times 30 plus 4 times 70. We can actually just see these two as 34s plus 74s is 100 times 4. So it's 70 times 30 plus 100 times 4. And now, this is going to be 2100 plus 400. And here we see where the 25 comes from. It comes from 21 plus 4. The 21 comes from 7 times 3, and the 4 is because the 4 is repeated. And it's only 4 times 100 because it's 70 plus 30, 7 plus 3, right? That creates a nice round 100 for us to multiply by. That's where we get this trick. So in conclusion, our last two digits are 16, which is 4 times 4. And our first digits are 7 times 3 plus the repeated digit, which is 4. 7 times 3 plus 4 equals 25. And that's how we do that. So in our next problem, let's try to do the same thing. 66 times 46. Do try to beat me to it. So I will write out the answer this time. The answer would be our last two digits as 36 and our first digits as 6 times 4 plus the repeated digit, which is 6. So we're going to get 6 times 4 plus 6 is 30. And now let's backtrack a bit and derive this just in case anyone is still confused. But if you did manage to write this down, congratulations. So it is 60 plus 6 times 40 plus 6. This will give us 60 times 40 plus 40 times 6 plus 60 times 6 plus 6 times 6. And now don't get confused with all the 6's because it is very easy to do that. But keep your eye on this. How many 6's do we have? We have 100 6's. So it's 60 times 40 plus 100 times 6 plus 36. So now we can see the first two digits of our number are 6 times 4 plus 6, which is 30. And our last two digits are 36. And so we are once again going to have 2400 plus 600 plus 36, which is 3036. Exactly what we got up here. So that is what I call one of the special cases of multiplication, where the last two digits of something add to 10 and the first digits are the same, or vice versa, the first digits of something add to 10 and the last digits are the same. Now, of course, we might also note that this is actually an extension of kind of our squaring numbers ending in 5 trick. It is more generalized. It is a little bit harder, but it does work on more numbers. So that is, once again, another one of our multiplication tricks. Not too hard to learn. Once again, it's always derivable by FOIL. If you ever forget this in contest, use FOIL. I'll see you next time. Thank you guys for watching.